Team Note-Taker representing the United States. This is Shashank Srinivas, software developer, Chen Yan, product designer, and Michael Ostrowskis, who's handled some of the electrical and mechanical work. Today we're going to be talking about the Note-Taker, which is a solution to help low vision students take notes in class. And the way that the Note-Taker started was actually that in 2007, I added a math major to my existing computer science major, and this was a problem because I'm legally blind. And so that means I have some vision, but not enough, for instance, to see a distant board. And so it turns out that the existing assistive technologies do not allow low vision students to take notes in the same amount of time with the same ease as their fully sighted peers. This wasn't a problem before the math degree because I just would spend a lot of time out of class trying to keep up with using textbooks, or in class I'd have a monocular, which is a very common assistive technology. It's like a telescope that you hold up to your eye. The problem with the monocular, though, is you have this great large board, and now that you have this board, you need to zoom in. So you zoom in, you have a limited field of view. So you take some notes, you look up, you find your spot, you have to commit something to memory, go down, write some notes, go back up. This cycling between notes and board incurs there's a delay there that will accumulate to the point where the low vision student can't keep up with his fully sighted peers. And this delay, this board delay, caused me to have to withdraw from several classes, which was totally foreign to me. It was unacceptable as a 4.0 student, and I'd never considered having to do that before. And so I frantically searched for other assistive technologies that are available for low vision students, and among them we have some cameras that you can connect to a laptop. These are cameras that you can manually zoom in and push and point at the board. But the problem with them is that they don't interact with tablet PCs well, and so you're only forced to take typed notes. And the problem with typed notes is that when you're in a science, technology, engineering, or math class, you're going to run into specialized notation or diagrams, and the keyboard just isn't sufficient for those. So those didn't work. Another assistive technology I used was the head-mounted camera systems. So these are a camera that you put on your head, and then there's some LCDs that you can see you can see the board zoomed in. The problem is that you have trouble taking your own notes because you can't look down now. And the other problem is that it's very alienating because you have this great big board, and now you're talking to people like this. It's sort of like a Darth Vader mask, and makes it difficult to interact with your peers in any sort of natural way. And in fact, when I was in a graph theory class, a friend of mine thought I was playing a Virtual Boy, an old Nintendo product, and in fact, I was just trying to keep up with note-taking. So those don't work. Additional technologies, we have digital whiteboards and camera-based lecture recording systems. They're typically meant for archiving lecture content for offline viewing, but they could conceivably be adapted to stream the content to a low vision student's laptop in real time. The problem with these is that not all universities are going to be able to equip these, and so you're forcing the low vision student to rely on the support personnel or building infrastructure that you can't assume exists at every university or conference or business that you might go into beyond his education. And finally, we have human note takers. So these are mandated, at least in the United States, by the Americans with Disabilities Act. In practice, it's another student in class gives a low vision student a copy of their notes after class. But the problem with that is that the research clearly shows that if you take your own notes, even if you never subsequently review them, then your retention is benefited. So we want to be able to allow the low vision student to take notes in class with his fully sighted peers and not have to spend extra time reviewing outside of class. So with these problems with assistive technology in mind, I realized that I was going to need to create my own assistive technology, new assistive technology, to complete the math major. And so the basic conceptualization of the Note-Taker began in that scenario. And so the idea was, let's take a tablet PC. This is a computer that you can sit flat on the desk, and it supports handwritten inputs, so digital pen inputs, so you can handwrite your notes. Let's connect to that a camera that can zoom in on the board. But now that the camera zoomed in on the board, we're going to need to reposition it. But let's allow the student to focus on his notes and focus on the board. So let's allow the repositioning to happen from the software directly. So to do that, we're going to put 2 servo motors underneath the camera so that you can do all the camera aiming and positioning programmatically. And then finally, we're going to need some software so that the student can take their notes on the laptop and control the camera very naturally. And we'd like to be able to allow that software to support handwritten or typed notes and lecture review. So the concept drawing that you saw can only, of course, be approximated by a prototype. And in fact, the first generation prototype, we got the software set up so that you have a digital notepad in one half of the screen, and you have live streaming view of the board from the other half, and you have this little tiny control panel with little itty-bitty buttons for incrementally moving the camera left, right, up, down, zooming in and out. And so this was a very kludgy interface, and in fact, the hardware we put together contained parts from Walmart that weren't particularly reliable, or they could break occasionally. But the concept, very kludgy as it was, clearly worked in class. In fact, I took it into an abstract algebra class and, the first time, and I was able to take my own notes, and I was just sort of emotionally overwhelmed afterwards because I realized that after class I wouldn't have to go back to my textbooks. I understood the material. I didn't have to have any extra effort in taking notes during the class. So the concept clearly worked, but it needed a lot of refinement, both in the software and the hardware. And that's when we assembled the team. So this was at Center for Cognitive Ubiquitous Computing, a research lab at Arizona State University. And our objective was to refine the software and hardware. So then we went to a second generation prototype. And part of this prototype was to allow the student to focus directly on the lecture material and also his notes. And so we did away with the little control panel interface and just had video and notes. And on the video, you could naturally just tap or drag your finger on it to control where the camera's positioned, much like the multi-touch interfaces of cell phones these days. And we also refined the hardware so that we weren't dealing with the problems of commercial off-the-shelf technology. We were using industrial components, much stronger servo motors that were more reliable and more accurate. And so we used this prototype and had a number of other low vision students using it in studies. And it was also, it was much more effective, but we still wanted to do some further refinement. And by that time, we had additional ideas on how can we help the student, not just during the class, but outside of class for reviewing the material. And so that's when we went to our third generation design of both the software and hardware. In the third generation, we support also not just taking notes, but reviewing notes. And so this feature, the thing is that we can record audio and video, and we know what time you're taking each pinch stroke or keystroke when you're taking your notes. So when you subsequently go back to review your notes, we don't just have to look at the audio and video in some sort of linear format, which is very time consuming, but instead we can look for our notes. We might find a place that we were not taking enough notes in. Perhaps you were sleeping, as I often end up doing, or perhaps you just weren't able to keep up in the class. And so you can highlight those notes. That gives us a collection of timestamps that you're taking those notes, and we can plug that into the video and audio that was recorded to start playing the audio and video from that time. So we can facilitate review. We also made it easier for students to just look at their notes by not having to do a file management. So classes notes are automatically filed by semester and class and time of day. So the student can just very quickly choose the class he's taking notes in. It sets up a new note-taking session, and he can quickly retrieve them and review as well. So the other thing that the third generation prototype, the software and hardware that we facilitated was with the improved design is making it more aesthetic so that users would be willing to use it in class, and also balancing the center of gravity. That was a major problem, so we needed to get the positioning of the camera through tapping and dragging to be very precise, and to do that we needed the camera to weigh as much no matter where it was panned or tilted, and that involved balancing the center of gravity. So with that, we're going to go to a demo with Michael Ostrowski.
Thank you. As David was saying, we wanted to emphasize that we want the student to be able to take their own notes in their own classes independently without any classroom infrastructure or support staff. So here we have one of the third generation prototypes. It plugs into the tablet laptop with a single cable. I get into class, I set them both up. When I run the application, I'm presented with the option to take notes or review notes. If this are a new class, I'd want to take notes. And then if I have a long class, I might put my laptop away. So I might want to resume my recording session or just start a new one, which is what I'm going to do now. I then choose my class, as David went over before. When I do that, on half the screen, I see what the camera sees. With simple gestures with my finger, I can move the camera around. Any feature that starts under my finger stays under my finger. With a simple stretch gesture, I can zoom in. Similarly, I can zoom back out. And normally, you'd be in a classroom, I'd be looking at a whiteboard or a chalkboard, of course, or even a presentation. So when I find what I want to look at, I can go ahead and read it. So on this side, I'm sorry, is Microsoft OneNote. That's the digital notepad. I can handwrite my own notes there. I can zoom in, I can move around. But sometimes it might be a little hard to read. I might have unideal lighting conditions, or the teacher's using a marker that's wearing out. So I can't quite make out what I'm seeing. For that, we added some image processing features, such as contrast enhancement here. Similarly, I can invert, which can really help bring out the what the professor wrote on the board, and then I can continue to write down my notes. Actually, another thing is a common frustration of mine in class and of many students is that the professor tends to walk in the way of the board while I'm writing. With a simple two-finger gesture, I can jump back to a previous frame where the professor wasn't yet in the way. I can continue to write down. When I'm caught up, I can go back to the live video. At the end of the class, I simply close the application, camera puts itself away, I can bag it up, bring it to my next class. Thank you.
Thank you, Michael. So as you can see, the Note-Taker eliminates the board note board delay by allowing a low vision student to quickly switch between viewing his notes and viewing the board. This is much like a fully sighted student who just glances down and glances up. It's portable, it's all battery operated, over 5 hours of battery life, connects to a tablet through a single USB cable, and it supports handwritten and typed notes. And so one of the key features of this was the API that we had to establish for the camera. So we have a number of servos in there, interface boards, and a big part of that was allowing, a big part of what makes the software work so well is allowing the camera to be controlled through tapping and dragging and pinching to zoom. And to do that, we need to establish a mapping between image pixels and motor coordinates. So the idea is that if I have the image, if the board's not perfectly centered, and maybe I want to click 200 pixels to the left, then I want the camera to pan so that it's as if the image translated by just 200 pixels. So to do that, we need to be able to move the motor very precisely, and that has to take into account the amount of zoom. So we have established an automated calibration procedure that relies on some computer vision work in this particular set of features. So that calibration procedure is what allows us to do the tapping and dragging and other gesture-based controls. The features, so you saw that we can take handwritten and typed notes. These notes can be searched offline so that you can even your handwritten notes can be searched through the Microsoft APIs, and it's actually very good recognition. You can't convert your notes to text, but you can. The recognition is good enough that you can search key terms and you'll find them with high likelihood. You saw that in class you have image enhancement. You have the look back feature. We also have image in notes, which is where maybe there's a diagram on the board and you don't want to spend the time drawing it, so you can just take a screenshot and drag it over to your notes, and you put a screenshot in your notes just directly in line in real time. For reviewing notes, we have the lecture materials archived by class and semester, and we can also review the notes with the synchronized audio, video, and notes, as I told you previously. So it's the technologies that we're using. The bulk of our software is written in C++. This was because we're controlling a camera and dealing with a lot of video and doing some image processing, so we need a lot of speed. We make extensive use of the Windows 7 SDK, including the multi-touch and inking APIs and gesture recognition and handwriting recognition. We also use the more venerable Win32 API for the graphical user interface and threading and serial communication to the different hardware inside the Note-Taker. We use a couple of convenience libraries like Qt and OpenCV for handling image processing and abstracting the graphical user interface. And in fact, using these libraries gives us an element of cross-platform capability. So our software has a limited version that compiles on Unix platforms, but we're sticking with the Windows platform for now because they're the only, Windows is the only platform with serious support for pin computing. Finally, we have Microsoft, we have a Note-Taker plugin inside Microsoft OneNote. So OneNote's a product of the Microsoft Office family. We have a plugin written in C#, which uses the .NET framework so that we can communicate between the Note-Taker and OneNote. This is an object model of our different components of our software. So you can see here, this is the pan tilt camera, which is allowing us to center on different points and while respecting the calibration. We have a collection of graphical user interfaces of the different windows that the user interacts with, and that's where the gesture recognition takes place. This is OneNote, where our plugin resides, and then there's a collection of modules that can be extended on the top right there. So you have things like look back and image processing. That's where we'd add additional features like, for instance, streaming video from having one Note-Taker in class and allowing that video to be streamed to other laptops in the class over a web protocol. This is the hardware architecture. You can see we have a large number of parts inside, and that's what makes our third generation prototype a little bit bulky. And in a future design, we'd be contracting the size down into, we'd be taking the 6 interface boards that we're using here and putting them into a single board that we designed. And we've also, so with the design, With the design, we've been doing user studies, so I've been using this for 2 years, and it's what saved my math degree and allowed me to maintain a GPA sufficient to be accepted in MIT for computer science PhD program this fall. We have another low vision student who's used it for a couple of semesters. Thank you. We have another low vision student who's used it for a couple of semesters and gave great feedback, and we've had another couple dozen low vision students who we've been interacting with and more focused usability testing. So what components of the interface do they like or don't they like? So for instance, we switched from single tapping for moving the camera to double tapping so that you don't get that confused with the zoom gestures occasionally. And then we're also engaging additional low vision students. So this fall we're going to be distributing 3 third-generation prototypes to users to use in the classroom, and they'll be using them for a month or more at a time. And we'll be having a rolling enrollment of low vision students to get additional feedback. And we all know that increased levels of education tend to correlate with increased income, and increased income tends to correlate with improved quality of life. But what might be a little less known is that of the low vision adults, 20 million low vision adults in the United States, fewer than 40% of them participate in the workforce. We believe that the inaccessibility of education is in large part to blame for this, and so we'd like to equip them with a portable assistive technology that makes the classroom accessible according to their needs without relying on others. So logistically, the way that we're going to do that is target the US market. There's about 20 million low vision adults here, and then initially target the US market and then go broader. There's 124 million low vision adults in the world. In the United States, what we need to do is, reduce the cost of our prototype. So right now our prototype, the shell of it, is printed using stereolithography or 3D printing. So there's a couple dozen components in there that we individually have designed and printed and assembled. We need to go from 3D printing, which is great for prototyping, but very expensive, to injection mold, which is a manufacturer would allow us to manufacture the device. We need to take the interface boards, which there's many of them, and bring them into a single interface board so that we can reduce the size of the Note-Taker as well. Also in the US, as a marketing concern, we actually won't be targeting the low vision students directly. Instead, we'll be making partnerships with state-based vocational rehabilitation agencies. So each individual state, the way that it works is that there's a vocational rehabilitation agency. They're responsible for allowing individuals with disabilities to become gainfully employed, and part of that's getting an education, and part of getting that education is having assistive technology that allows you to pursue it. In the broader market, though, we see that the Note-Taker could be useful for not just low vision students in the United States and other developed nations, but also for low vision individuals in developing nations like India and China, where typically right now they're tracked into a different category, a different school system where as history shows, they tend to have access to a poorer quality education. So we'd like to provide a lower cost Note-Taker for developing nations on the order of $100 to $200, so that there's a hope that low vision individual students can be brought into the mainstream education systems in the respective countries. So we'd like to, that's sort of a tier 3 model, and that would be a camera that does not have servo motors or a motorized zoom lens. It would just be manually adjusted zoom and manually adjusted pan and tilt, and it would connect to a laptop, for instance, the XO laptop, the XO3 laptop, which is expected to have pin input, hoping that it comes out. The second, the tier 2 Note-Taker is going to be the current design once it's in a manufacturable state, and that will be marketed to low vision individuals in developed nations. And so again, that'll be going through the vocational rehabilitation agencies. And then a little bit into the future, we have the tier 3 design that is going to be no moving parts, ultra high resolution sensors. So we have cameras that can stream at 16 megapixels. And once you get such a high sensor resolution, you don't need an optical zoom lens. And once you don't need the optical zoom lens, you don't need motors to pan and tilt. So you can just have a camera that points at the board directly. You can zoom in digitally, pan around and pan and tilt around digitally, and it's all instantaneous. So it'd be a much smoother experience. So we envision having a product like that for around $2,000 in the next 3 years. And finally, we'd like to not just target low vision students, but we'd like to help fully sighted students. And the way that we can do that, we think, is that the current design is pretty expensive, and it's probably not a cost that fully sighted students would be willing to bear as it exists. But that tier 3 model that we're targeting to low vision students in developing nations could be also targeted to fully sighted students around the world. And there's over 200 million in the United States and the European Union alone. And so we think that they would like to be able to use the Note-Taker for being able to record their lecture materials and being able to review them later with the synchronized audio, video, and notes. So So we think that the Note-Taker, we'd like to get it in the hands of students, not just low vision, but also fully sighted students, so that they can focus on just recording their lecture material and quickly reviewing it, and so they can get their education and become employed. Thank you.
Hi there. In your user testing and usability testing, what was the one most important lesson you took away?
Sorry, I was looking for the hand mic question.
In your user testing or usability testing, what was the one most important lesson this team learned?
I think the biggest problem is that how to make the product that is not alienating the student from others. So that's why we do all these usability tests to see what the user experience actually is, from actually carrying this device to the classroom, to setting it up, and to taking notes and then packing again to another class. That's a whole user experience process. We want to test the whole process and find out is there any improvement we need to make the whole user experience better.
Thank you.
Your system is battery powered, correct?
Correct.
How long is the battery life of the device? Would it run a whole day's worth of lectures?
It definitely would. The internal battery lasts roughly 6 to 8 hours and charges again in about 1 hour.
And that's lithium ion, is it? Or is it?
I believe so.
Okay, thank you.
Great demo, great concept. Have you shown it to any state agencies and any institutes for the blind? And if so, what were their comments about it?
So we definitely have shown it to both of them. So the organizations for the blind, a recurring theme in assistive technology is always make the cost as low as possible. And so that was sort of the feedback, just get the cost lower. But I think that we're on track for that because the existing high-tech assistive technologies are about $3,000 on the market right now. And once we reduce the cost of the manufacturable design of the current Note-Taker, we're targeting $1,000, $1,500 for the student. And when you consider the price of tuition, we think that that's very reasonable. If you even save one semester worth of withdrawn classes, as was my case, that would pay for itself. And to answer your other question, the state-based vocational rehabilitation agencies, we have definitely been in communication with them. In fact, I work with them individually because I'm a low vision student myself, and so they're very excited about it, and at least in Arizona, and we're working on building partnerships. But we need a manufacturable design first.
Thank you.
So you did a very good survey of the market. Have you ever talked to venture capitalists for sponsorships and information?
We spoke to venture capitalists around the time that we were developing the third generation Note-Taker, and I think both parties felt that we need to further develop the concepts of the software in the second generation prototype that was just for viewing the material in class, and the second generation has exposed servos and gears, and in fact the camera's it looks pretty professional, but the camera's housed in a Skippy peanut butter jar, and for the second. So at the time that we spoke to them, it was clear that we needed some additional development. So we're looking at doing that here in the near future now that we have the third generation, but we're going to go through the user studies this fall in the classroom first.
Thank you very much. That was an excellent presentation. I was like you to elaborate a little bit further on the cost savings. It implied to me that the solution for the developing nations may be actually decreasing functionality and sort of stepping back to re-emerging some of the problems you found. And I just wondered if there was alternative ways of making it much cheaper.
So there's two approaches that I see for reducing the cost dramatically. The first is is the tier 1 product, tier 3 Note-Taker, which is the no servo motors, no mechanical zoom lens, and just manually would adjust these things. And you're right, there would be reduced functionality in the sense that you have to manually move it, which is not technically a word delay, but it's a different kind of delay that we don't want to force on the users. And so that would be the most straightforward way of reducing the cost and complexity and durability and increasing the durability of the product. A little bit more of a future approach that will apply in the years to come is that we have this tier 1 model, which is the very high resolution sensor. So once you get, like I said, once you go to 16 megapixels or more, then you can start, so we did a survey of different classroom sizes, and at ASU, they fall between 5 and 40 feet, the distance between the front row and the boards at the most extreme distance. And so at 16 megapixels, you can accommodate any of those distances with digital zoom alone. And in fact, right now, cell phones are about 5 to 8 megapixels cameras, and they're going to be continuing to improve to the point where in 2, 3, and maybe possibly 5 years, we're going to have 16 megapixel cameras on the cell phone, so you could stream the images from the cell phone to a laptop. And once your imaging device is just a cell phone essentially on a tripod, then I think that that will also be a great way of reducing the cost.
Great presentation, an amazing product, I think. How big is the difference between the markets between selling the product to institutions against how those expectations in the market from personal users who may want to buy the product themselves?
I think, so to understand your question a little bit better, you're asking what's the difference in expectations between the market when we're addressing, for instance, the state-based vocational rehabilitation agencies versus the low vision students directly?
Yeah, basically, some institutions will buy the product and keep it in-house, but how big is the market for users who just want to buy the product and use it wherever they want to use it?
Right. So there's, as we said, there's 20 million low vision adults in the U.S. Not all of the working age adults. Not all of those are going to be students. So that's one market, and again, the way to address that is the state-based vocational rehabilitation agencies. The other side, another approach though, is to sell devices directly to the schools, and then those schools could actually rent out the devices to students as they need them. And this could be used for also both developed nations and in developing nations scenarios. Does that answer your question? Thanks.
What's everybody's role on the team?
So I came up with the original concept of the Note-Taker and built the first generation prototype, and that showed promise. So then we assembled the team for the second and third generation. So Michael has handled the mechanical and electrical design, so there's a bunch of boards and a lot of wiring and soldering. In fact, we were soldering yesterday, unfortunately, before presentation. So Michael handles the electrical and mechanical part. Chen handles the product design, so he works with the users, works directly with the users and designs some of the experiments, and is also responsible for making our product come from a Skippy peanut butter jar to something that looks nice and that you might actually be willing to buy. And then Shashank does software development, and that's what I do as well.
That was awesome.
Thanks.
Can you see a scenario where you install your system in a lecture theatre as opposed to having it actually used by people walking around? Would it become part of the infrastructure of the lecture theatre instead of actually being a portable unit?
So I didn't quite hear you, but I think you asked, can I see the system being used by the institution installed in the classroom? Is that right? Yes. So the original intent of the Note-Taker was to not do that because not all institutions are going to have this set up, and we wanted a solution for low vision students right now immediately. But one of the markets in these for the first two Note-Takers is actually long distance education, and this includes students who don't attend the class, maybe they missed it, or for streaming classes to the internet, so you can have a larger student body. And so definitely, I think that the tier 1 and the tier 2 Note-Takers are definitely candidates for that. And in fact, our Note-Taker is a pan-tilt zoom camera, and there's other pan-tilt zoom cameras on the market typically meant for security, but ours is the only one that is gesture controlled and the only one that connects through a single USB connection. So those are features that I think simplify sort of the infrastructure cost of implementing it. So I think that is something, we've had a number of professors, for instance, come up to us and say that they think this would be very useful. So we do think that there's potential there.
And I noticed that OneNote is at the core of your system. And did you run into any particular obstacles interfacing with OneNote? How'd you overcome them?
Funny you should ask that. So there's one of the things that we'd like to do. So like I said, we can highlight the notes in OneNote, and those give us a collection of timestamps and allows us to play audio and video. Another feature that we wanted to do that was just sort of a nice to have feature, it wasn't critical, was when the audio and video is being played, it'd be nice to be able to highlight the notes that were being taken while a video and audio is running. So it turns out that when we implemented this, what you have to do is you have to take the XML out of OneNote, modify it so that you say these series of pin strokes or keystrokes are highlighted, and then put it back in. So there turns out that there's a bug in OneNote where in the SDK where when you put that XML back in, even if you don't modify it at all, everything shifts down. So you keep doing this, many times a second, and it keeps shifting down. So we filed a ticket with Microsoft, and they said, well, we're going to work on it.
Splendid stuff. One of the students at Hull, we had a successful student. He had visually impaired. He had to work very hard to get through. Yours just makes that easier. That's lovely to see. Thank you. We're back here at 4 o'clock with the team Simplex from Romania. Thank you very much.